Hi, welcome back to Mrs. Thompson's classroom. We're going to continue our unit on the trig identities, and today we're going to look at summation and difference identities. And so let's get started just by taking a look at what these formulas are. So you can see here we're talking about summations and differences. So we're doing cosine and sine at x plus y or at x minus y, where x and y are the angles that we're using. And so we're either going to be, if we're doing a cosine of a plus, we'll be subtracting, and if we're doing a subtraction, we'll do a plus. But for sine, it stays plus and plus and minus, okay? So where do these formulas come from? Well, I'm going to take a minute to show you this difference of a cosine. And so let's take a look at why and where these come from. So let's take this picture. This is our unit circle. So we're going to assume a radius of 1. Okay, and I've labeled some points. So this blue angle is angle B. The red angle is angle A. And so their points on the unit circle are cosine and sine of their angle. So that's point R and point Q. Okay. Now, if I take and subtract B from A, I get this green angle. And so P is the point of cosine of A minus B and sine of A minus B. Okay. And so if I take this distance here, PS, okay? Now, the distance formula tells me that I'm going to take the square root of the x values squared minus the y values squared. So our distance formula is x1 minus x2 plus y1 minus y2 squared. Okay, so for PS, that means I'm going to take cosine of A minus B minus 1 squared plus the sine of A minus B minus 0 squared. And then I would take the square root of that. Okay, so that's this distance here. Okay, now let's take a look real carefully though, because if I go to angle A over here in the red, then this distance, this angle here is also A minus B. So that means this chord from Q to R is going to equal the chord PS. Those two chords are going to be equal to each other because they subtend the same angle. So let's look at what the distance QR is. So QR is going to be the square root of cosine of A minus the cosine of B squared plus the sine of A minus the sine of B squared. Okay? Now, if QR is equal to PS, that also means that QR squared is equal to PS squared. So I can get rid of the square roots. And so now let's FOIL some things out. So if I FOIL let's deal with QR first. So this will give me cosine squared of A minus 2 cosine A cosine B plus cosine squared of B. Plus, now let's FOIL this part. That'll get me sine squared of A minus 2 sine A sine B plus sine squared of B. So all of that is QR squared. And that's going to equal PS. So let me put different color on it there. So PS squared will be from up here. So we're going to take and FOIL this out. So I'll get cosine squared of a minus b minus 2 cosine of a minus b plus 1. And then I'll do this part. Well, that 0 just makes that sine squared of a minus b. Now, these two things are equal to each other. So now I can start simplifying some things. Well, we also want to remember that we know that sine squared plus cosine squared is equal to 1. That's our Pythagorean identity. So cosine squared of a and sine squared of a together will make 1. Okay, that also tells me that cosine squared of b plus sine squared of b is going to make 1. So that makes QR squared become 2 minus 2 cosine of a cosine of b minus 2 sine of a sine of b. Okay, equals. Now let's look at the blue part. Let's look at PS. So on PS, we also have a cosine squared plus a sine squared. So together, that will make 1. And then I also have this 1 right here. So I will get a total of 2 minus 2 cosine of a minus b. Okay. Now I notice that I have a 2 on both sides, so those can subtract out. Okay. I notice that everything else is divisible by 2. So if I rewrite this, I end up with negative 2 cosine of a cosine of b minus 2 sine of a sine of b equals negative 2 cosine of a minus b. So dividing everything by 2, I now have cosine a, cosine b, sorry, I'm going to divide by negative 2, plus sine of a, sine of b equals cosine of a minus b. So we have our identity. Right. Now a similar proof can be made for a plus b. We define our angle just a little bit differently, but we could do a very similar thing. We set up a and b, and then we draw their sum coming around the circle clockwise and going around the circle counterclockwise in both directions. And so we find 2 equal chords, but related to angle A plus B. And so we can get the same sort of identity doing it that way. And then once we know cosine's formulas, we can prove sine's formulas. Okay. All right, so hopefully that gives you a little bit of understanding of where these formulas come from. Let me go back here and show you what the formulas look like in case you need to write those down again. In my next video, we'll go over some examples of using these formulas and what that looks like. So hopefully you'll join me then. Be sure to like and subscribe down below if you want to, and we will see you next time.